Hi, this is Mrs. Youd, and today I'm going to teach you Chapter 9, Lesson 6. This is solving systems of nonlinear equations. Now, just like linear equations, there are three ways to solve them. You can solve by graphing, or by substitution, or by elimination. And so we will practice all three of those today. A system of nonlinear equations means that it has at least one of the equations is nonlinear. So the other one can be linear, and that will be the case in all of our practice ones today. We will have one that's going to be quadratic and one that will be linear. As you can see, I'm starting on page 304 of your journal today, and so we're just going to do page 304 and 305. So I'm going to start number one by seeing if I can factor the quadratic to see if I can find my zeros. So that would be x plus 2 and x plus 3, which means that my zeros are -2 and -3. So I'm going to go ahead and draw those in, -2 and -3. So that means that my axis of symmetry has to be right in the middle at -2.5. So now we need to plug in -2.5 into that equation to see if we can find what the vertex is. And when I plugged it in, I got -0.25. So that means my vertex is just underneath the x-axis there. My equation tells me up here that the y-intercept is at 6, which means that I can draw another point on the other side like that. Before I connect this in a U shape, I'm going to go ahead and draw my other equation, which is a line, y equals -x plus 1. So my y-intercept is at 1, and my slope is a perfect negative slope. So there's my line. I can see from the graph that I have one answer already because this point here is shared by both the quadratic and the line. So that means one of my answers has to be -5, 6. Now, if I were to draw my quadratic here, it probably will pass through this point here. So I'm going to see if that's true or not by plugging in -1 into the quadratic to see what comes out. And when I plug in -1, I get 1 minus 5 plus 6, which gives me +2. So that means that -1, 2 is indeed on the quadratic. And that is the point here, which makes sense because that's where it looks like it would be intersecting. So I can finish drawing my quadratic equation there. And now I have my other answer, which is -1, 2. And so these are my two answers for my system of nonlinear equations. All right, let's take a look at number 2. First thing I'm going to try is see if I can factor that. So I get x and x, one of them is going to be plus and one is going to be minus. The only thing that multiplies to 3 is 3 and 1. But 3 and 1 do not add up to this middle term, so that means that we cannot factor that. So what we're going to do instead is use -b over 2a to find our axis of symmetry. So our A number is 1, our B number is also 1, and our C is -3. So I'm going to write -b, so -1 over 2 times A, which is also 1. So that would be -1/2. So now I know that my axis of symmetry is at -1/2, which is right here. So now I'm going to plug in that -1/2 in order to find my vertex. So that would be -1/2 squared plus -1/2 minus 3. And when I do that, I get -3 1/4. So that puts my vertex right here. I can see from my equation that the y-intercept is going to be -3, so I can put a point there and there. And I think I need to plug in a few more points here to see what some of my other points are going to be so that I can have a nice U shape. So I'm going to plug in a couple of other points. Let's plug in a 1 and see what we get, and we'll go ahead and plug in a 2 as well and see what we get. So when I plugged in a 1, I got -1, so I can put a point here and here. And when I plugged in a 2, I got 3, so that means that I can put a point here and also here. Okay, so that's probably going to be enough. I'll go ahead and connect my dots. And now let's move on to graphing the line. So my line has a y-intercept of 1, and it has a slope of up 1 over 1. So I'm going to go ahead and draw that here. And I can see where my answers are going to be right away because I can see where they connect. Those two connect here and here. So my final answers are going to be -2, -1 and 2, 3. On number 3, since I have a fraction in front of the x squared, I'm not going to try to factor that one at all. I'm just going to go ahead and go straight to the -b over 2a. So -b over 2a would be negative, my b number is -2, and my a number is 1/2, so 2 times 1/2. So that gives me +2 on the top, and these cancel out to a 1 on the bottom, so the axis of symmetry is at +2. So now I'm going to go ahead and find out what my vertex is by plugging in 2 into the equation and seeing what I get. And I got 2, -1 as my vertex, so I'll go ahead and plug that in. I can see from the original equation that my y-intercept is at +1, so I'm going to go ahead and draw that there. And for the sake of this problem, I will go ahead and plug in a 1 to see what I get out so that I can put a point there. And I will also go ahead and plug in a -1 to see what I get. Okay? Why don't you go ahead and finish this problem, pause the video, and then turn it back on to see if you get the same answer I do. Okay, I got 0, 1, and 2, -1. If you did not get that as your answer, see if you can find your mistake. For the sake of time, I'm going to go ahead and skip numbers 4, 5, and 6 and move on to solving the equations using substitution. Now remember, when you use substitution, you find one of the variables is equal to something, and you're going to take that and plug it into the other equation. So now this top equation is 6 minus 2 is equal to x squared. So that gives me 4 equals x squared. And now I need to get rid of the square by doing the inverse, which is taking the square root. So I end up getting x is equal to positive or -2. That means that my answer are 2 points. So we have 2 comma something and we have -2 comma something. And those are going to be my 2 answers. So what I'm going to do now is plug in 2 and -2 into one of my equations. But actually, I don't have to really do that, because if you notice, this equation here tells me that y is always going to be 6. So that means that I can put that in as my answer for y, and I'm done. Okay, let's move on to number 8. So on number 8, they both equal y, which means I'm going to take one of these and plug it into the other one there. So that means I have -2x squared is equal to 3x plus 2. So I'm going to, in order to solve quadratic equations, you need to get everything over to one side. So that would give me -2x squared minus 3x minus 2 is equal to 0. So if I look at this and I try and think about factoring it, I know that I can't factor this one. So that means that the easiest way to solve this would be to use the quadratic formula. So if you remember, we used the quadratic formula in the last lesson. So I need to find my a, b, and c. A equals -2, b equals -3, and c equals -2. So I'm going to plug it in. X is equal to -b, so -3, plus or minus the square root of b squared, -3 squared, minus 4ac, so 4 times a times c, over 2a, so 2 times a, which is negative 2. You'll notice that I was singing the Pop Goes the Weasel to help me because that's how I learned to memorize it. All right, let's go ahead and simplify this. And I noticed that even right away, I noticed that this, what's inside the root, is going to be negative, which means that if we were to graph these two equations, they would never intersect. They may look something along the lines of this. So as you can see, they're never going to intersect. So the answer is no solutions. On number 9, they both also equal y, so I'm going to take x minus 4 and substitute it in there. So we have x minus 4 is equal to x squared plus 3x minus 4. So I need to get everything to one side of the equation, so I'm going to subtract the x off here and add the 4 here. And so that leaves me with 0 equals x squared plus 2x. So this one is easily factorable, so I'm going to take out an x, and I'm left with x plus 2. So that means that my x answers are 0 and negative 2. So I have answers, I'm going to put them up here, 0 comma something and negative 2 comma something. So what we need to do is substitute in the 0 into either equation and also substitute in negative 2 into either equation. I'm going to use the top equation, y equals x minus 4, because it's a little easier to use. So if we plug in a 0, 0 minus 4 is negative 4. So if we plug in a 0, we get negative 4 as an output. Now let's plug in negative 2. So we have negative 2 minus 4, which gives us negative 6 as an output. So if we were to graph these two equations, we would see that they would cross at 0 comma negative 4 and negative 2 comma negative 6. In the next 3 problems, we need to solve using elimination. So you'll notice that things are not stacked correctly. So I'm going to rewrite both of these. So we have y equals x squared, and then I'm going to put y equals, and I'm going to move the x minus 3 here because I want to put a column that has the squareds, one that's just x, and then one that's the numbers. So if you remember from elimination, you want to try to eliminate one of the variables. In this case, I can eliminate y by subtracting the second equation from the top equation. So if I subtract that, I get y minus y, which is 0, and then x squared. And then now I need to distribute this negative here, so I have negative x and distribute it here as well, so I have plus 3. So now what we can do is we can go ahead and solve this equation. So I first check to see if it's factorable. There's nothing that multiplies to positive 3 and adds to negative 1, so it's not factorable, which means we need to use the quadratic equation. So we have a is equal to 1, b is equal to negative 1, and c is equal to 3. So I'm going to plug these into the quadratic equation. X is equal to negative b, so that's negative 1, plus or minus the square root of b squared, so that's negative 1 squared, which is 1, minus 4 times a, which is 1, times c, which is 3, all over 2a, so that's 2 times 1. So first of all, I noticed what's in here is going to be a negative number. 1 minus 12 will give me negative 11, which means we will have a negative under the root. And so that means that these two sets of equations will never intersect, so there is no solution. For number 11, I'm going to rewrite the two equations again, making sure that everything is stacked properly. So the first equation will stay as is, and the second equation, I'm going to move my 3x over to here and my minus 1 to here. So I'm going to subtract these two equations again, just like we did before. And when we do that, we get y minus y, which is 0, and then x squared. And then we have negative 3, so it would be 3x minus 3x, so that's 0. So these cancel as well. And then negative 5, don't forget to distribute the negative, so it's actually negative 5 plus 1, so that's minus 4. So this turns into kind of a simple problem because the bx isn't there. So if I move my 4 to the other side, I get 4 is equal to x squared. Take the square root on both sides, and I get x is equal to plus or minus 2. So that means that I have two answers. I have a 2 and a -2 as my x's, and so now we need to substitute in those two numbers into one of our equations. Of course, the easiest equation to substitute that in would be the second one, so I'm going to do that next. So we have y is equal to 3 times +2 minus 1, so that's 6 minus 1, which is 5. And now I'm going to plug in the -2. So y is equal to 3 times -2 minus 1. So that's -6 minus 1, which is -7. So here are my two answers for number 11. That is where they would intersect if we were to graph these two equations. I would like you to try number 12 on your own and see how you do, and then turn the video back on to see if you got it right. All right, I got 4,18 and -4,10. And if you didn't get it correct, see if you can find your mistakes. We're going to skip 13 through 18 for this lesson, so we're finished for now. This has been Chapter 9, Lesson 6, which is solving systems of nonlinear equations.